Hey guys, today we are looking at 7.3, which is all about complex fractions. So a complex fraction is kind of like a fractionception. It's a fraction within a fraction. Both the numerator and the denominator, or at least one of them in that fraction, is a fraction. So not very nice, not very ideal, but we've got two different ways that we're going to be able to handle this. And it's going to be personal preference. I'll show you guys both methods, and then from there I'll just let you guys choose whichever one makes the most sense to you. So if we're dealing with a complex fraction, our first option is to multiply by the reciprocal. We know that if we're dealing with a fraction, let's just say we have a half all over 3 over 2. That is what a complex fraction looks like with just numbers involved. We got a fraction up top, a fraction underneath. We know that in a fraction, the operation of a fraction is really division. So this I could rewrite as 1/2 divided by 3 over 2. Right? A fraction is just numerator divided by denominator, which we know dividing by a fraction is the same thing as multiplying by the reciprocal. So when we multiply by the reciprocal, then we can cancel anything that's in common and simplify it down to just our final answer. So that's option number 1. If you have a complex fraction, multiply by the reciprocal. You're just flipping the denominator fraction over and multiplying by the numerator's fraction, and then simplifying from there. Our second option is to find the LCD of both the numerator and the denominator and multiply by that number. So if we started with the same fraction, same complex number, not complex fraction, 1/2 all over 3 over 2. If I were to identify the LCD of my denominators, I have 2 denominators, there and there, right? My LCD, my least common denominator of those 2 denominators, is just 2. It happens that in this case, my denominator is the same. So I know I'm allowed to multiply in a fraction as long as you did the same thing to the top as you did bottom. So I can multiply here top and bottom of my fraction, my complex fraction, by 2. And what ends up happening there, when you multiply your numerator by 2, the 2's cancel, and you're just left with 1. In your denominator, your 2's cancel, and you're just left with 3. And hey, look, we still end up with the same simplified answer as we did up in method 1. Now, there's some pros and cons to both of them. The nice thing about method number 1 is that you don't have to find a GCF or an LCD, and combine those fractions together. You don't have to work on finding an LCD, which some of us really struggled with in 7.2, 7.2 when we were adding and subtracting. But we do have to do that in method 2, but then afterwards it's usually much quicker to go through and simplify and have your answer before, without a lot of extra work once you've found that LCD. So it'll be kind of, just feeling it out, seeing which one you guys like best. So what we're going to be doing here is simplifying 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. So if I'm going to do option 1 here, which is my multiply by the reciprocal, by my flip it option, before I can flip it, I need to have just a single fraction over a single fraction so that I can flip it up, multiply by the reciprocal. So my first step for box 2 is going to be focused on simplifying that denominator. My 1 over x plus 4 plus 2 over x has to get added together so that I have just a single fraction in my denominator. So if we do this like we did yesterday, or like we did in 7.2, x plus 4 plus x as my 2 denominators, well, if I multiply by what's missing, my first fraction is missing the x in order to be a common denominator. My second fraction is missing the x plus 4 to make this a common denominator, which tells me x over x times x plus 4 plus 2x plus 8 all over x times x plus 4. So when I simplify and combine my like terms, I'll switch it up and do red here. My top fraction did not change, 5 over x plus 4 all over. When I combine my like terms, 3x plus 8 over x times x plus 4. Right, because x plus 2x is 3x, and then my 8 is still just there. So now that I have this as a single fraction over a single fraction, I can go ahead and flip and multiply. So now, when I change this, my top fraction does not change, 5 over x plus 4. But now this is getting multiplied. My denominator becomes my numerator, and my numerator becomes my denominator. So I'm flipping that denominator, that bottom fraction, flipping it up. And now I can just simplify like I did in 7.1. I'm multiplying here, so I can see I've got x plus 4s in common, and that's all that cancels. So my final answer, after I've multiplied them together, up top I have 5 and x. Down below I've just got that 3x plus 8. So that would be my final simplified answer. What I have to be careful with here and what I have to look at is from my original problem that I started with to this, what was in my denominator that is not any longer. So we definitely know the x plus 4 got canceled out from top and bottom. So negative 4 would be that solution, right? X plus 4 equals 0. Subtract 4 on both sides, negative 4. But I also originally had just an x value in my denominator that's not there anymore. So in my original problem, I had x in my denominator for the bottom right term, what I'll highlight here in yellow. This one started off with just an x in the denominator, which would be a 0. But because of the process, because we ended up flipping it up and simplifying it down, that x equals 0 is another excluded value. Even though it didn't get canceled, it started off in my denominator and is not there anymore. So in my original problem that I started with, if I had that 0 for my x value, it would give me a 0 in the denominator, which is an issue. So again, I need to list that in my excluded values. So it's the first time we've seen that. It's not just something that's been canceled out, but something that was in my denominator that's not anymore. Okay. So that's option 1. Option number 2. Same exact problem, 5 over x plus 4 over 1 over x plus 4 plus x over 2, 2 over x. So now this one, we're going to be multiplying by the LCD. So in my 3 denominators, 1, 2, 3, my LCD is actually the exact same LCD we just figured out in the last one. I have an x and I have an x plus 4 in my denominator for all 3 of my denominators. So what I'm going to do is basically all of my fractions in my complex fraction here are going to get multiplied by x times x plus 4. So I'm going to go ahead and just x times x plus 4, x times x plus 4, x times x plus 4. And the reason I'm doing that is because now my x plus 4's cancel out, leaving me with 5x up top. My x plus 4's cancel out, leaving me with just x for this first term. Here my x's cancel out, leaving me with 2 times x plus 4, which would be 2x plus 8. And then I collect my like terms, 5x over 3x plus 8. And hey, look at that. I end up with the exact same solution, 5x over 3x plus 8, as I did from box number 2. That is the flip it method. The only thing I still have to do, just like before, I have to make sure I list out my excluded values. So besides my simplification, I also have to make sure I list those out. So here, same thing. My negative 4 got canceled out. My 0, we can see in this method, is a little bit more clear that it was canceled out, and that's just because of being flipped out of the denominator. But I can see that it has been canceled out through that process. So that makes it, for me, a little bit easier of my methods. I can distinctly see if something was canceled out. I have to list it in my excluded values, not just it disappeared because it got flipped. I definitely like option 2 better. I like multiplying by the LCD. It's a little bit easier for me. I just find the LCD because I'll probably have to do that anyway in my problems. So I might as well just find an LCD once, multiply through, and be done with it. So box number 4, you choose. Here we got a new problem. Again, whichever one you prefer, go ahead and try that method. I'm going to go through and do this with you using option 2 because, like I just finished saying, that is my preferred method. I'd rather do an LCD and then cancel out what's in common. So if I'm going to do that this method, if I'm going to use that method for this one, my LCD is anything in my denominators. So I have x plus 5s, and I have an x minus 3, and that's it. Those are the only two terms, two parentheses, two factors that show up in my denominators. So I'll go ahead and just multiply x plus 5 times x minus 3, x plus 5 times x minus 3, x plus 5 times x minus 3, and now cancel whatever's in common. X plus 5s go away. Up top we've got 3 times x minus 3, so that's 3x minus 9. Here my x minus 3s go away. 2 times x plus 5 would be a 2x plus 10, plus my x plus 5s cancel out. 1 times x minus 3 is just x minus 3. So now we end up with 3x minus 9 over, let's see, 3x plus 7. And it is really, really tempting to just cancel out those 3 x's. But again, they're attached to the constant next to it with either addition or subtraction, depending on which one you're looking at. So that's as far as I can simplify it. All I have to do is go back and see what factors were canceled out. So in this case, x minus 3 was canceled out. So that means 3 is a restricted value. X plus 5 got canceled out. So that tells me negative 5 is also restricted. All right, that's all I got for you guys for 7.3, complex fractions. So your homework down there at the bottom is page 389. We're doing 39 to 44 all, so both evens and odds, but just from 39 to 44. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, and dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.